Today we're going to look at something called direct variation. What that is it's when two quantities, x and y, show a proportional relationship. So when we're looking at this, the graph of your line, if you graph your line, it's going to pass through the origin. If that's the case, it's going to show direct variation. Or your points are proportional. So when I look at direct variation, I look at it as being like, well, x and y are going to directly affect one another. So it's like if I times x by 3, it's going to equal y. If I divide x by 4, it's going to equal y. Right away. It's not saying I'm going to take like x times 2 and then plus 6 to get y. So direct variation, it's when these two things are proportional to one another and it's going to pass through your origin. So when you plot points, if you want to identify it using a graph, plot your points, draw your line to determine whether they show the direct variation, and then explain. So if we're looking right here at our different points, okay, I can see the point 1, -2 goes here, 2, 0 goes here, 3, 2 goes here, and then 4, 4 is here. Plot the points, connect the dots, draw your line. This line does not go through the origin. Therefore, this does not show direct variation. X and Y do not vary directly. Direct variation. Ooh, so sloppy. So let's take a look at the next one. You can almost tell right away if you have the point 0, 0 in your set of solutions here, you're going to know automatically it's going to show direct variation. But let's plot it and see. So 0, 0, 2, 2, 4, 4, 6, 6. And because these lines, or this line goes through your origin, yes, because it goes through both origin, it does show direct variation. So if you're looking at this, to get from x to y, you're only going to do one thing to it. In this instance, it's going to be y equals, and then for this one, it's x. I'm going to take x and times it by 1 to equal y. So if x is 2 times 1, y is 2. If x is 4 times 1, y is 4. If x is 6 times 1, y is 6. So when you look at direct variation, it's like I'm going to plug something in for x, and I'm either going to multiply or divide it by a value, and it's going to give me y right away. That's direct variation. So when we're looking at a table to determine whether x and y show direct variation, simplify each ordered pair. If they're the same, then the relationship varies directly. So if you're taking a look at this first table, you have x, you have y. I always do y over x because of slope. So 4 to 1. You've got 8 to 2. You've got 12 to 3. And you've got 20 to 5. If you look at those ratios of y over x, each and every one of them is going to reduce to 4 to 1. Okay, that's 4 to 1, that's 4 to 1, that's 4 to 1. So yes, these, if I plotted these points, they are going to go through the origin. Another way to kind of look at it is look at the pattern. If you're going from 3 to 2, 2 to 1, the next step down, so 3, 2, 1, you're going to get 0. If you're going from 12 to 8, that's minus 4. 8 minus 4 is 4. 4 minus 4, well, it's going to be 0. So the next ordered pair in that chart is going to be 0, 0 in that pattern there. So does it show direct variation? Yes. And then it says to simplify it, and it says why? Because they reduce the same. All right. You can already tell in the number 5, this one here, that these are not going to reduce the same. You have 5 to 3, you have 7 to 4, you have 9 to 5, you have 19 to 10. So no. There's the bell. No, this does not show direct variation because they do not reduce the same. I'm sure that there is a pattern, but it's not direct variation. They don't reduce. So direct variation means I'm going to do something to x to get to y right away. I'm going to multiply it by a value. I'm going to divide it by a value, and it's going to equal whatever y is right away. It is not when I take x and multiply it by something and then add, or x divided by something and then subtract. That's not direct variation. Okay, so let's take a look at this guy here. Automatically, you can see, yes, it does, because it goes through the origin. Okay, so just write yes. All right. So the graph below models the relationship between the time x in hours Janet works and the amount y in dollars she earns. So right away, you can see that this one is going to show direct variation. It goes through the origin right there. So if you look, I've got the point 0, 0. I've got this point right here. Goes through it. Each of the other points do not fall directly at an intersection of the two lines, the axes there. So one thing you're going to look at is it says write an equation that represents the solution, or the situation, excuse me. So it's always going to be, when we write an equation for this, it's always going to be y equals, for direct variation, something times x. Whether that something is a fraction or an integer or whatever, it's going to be y equals something times x, never plus or minus something else. So when we look at this, write an equation represents it, I'm looking at my slope. This right here is going to be whatever I'm doing to x to get to y each time. It's going to be actually your slope of your line. So I'm going to take the one point that I have. I have the point 6, 60, and I have the point 0, 0. I have those 2 points on here. I'm going to find the slope of this line. Okay? So if you take 60 minus 0 over 6 minus 0, you're going to see it's going to be 60 over 6, which is going to reduce to 10 to 1. Nope. 60 over, why am I saying 6? It's 5. Oh my goodness, it's 5. Just kidding, just kidding. It's 12. So 60 divided by 5 is 12. So what we see here, when you say to write the equation that represents the situation, well, you're going to take x times it by 12. So whatever x is, 1, 2, 3, 4, 5, times 12 is going to equal y. So this point here is going to be 112. You'll have 2 and then 24. You'll have 3, 36. Okay, so writing your equation that represents the situation is y is going to equal 12 times x. You take your slope. Okay. Interpret your slope. When it says to interpret the slope, what that means is, what does the slope mean in terms of the problem? In this problem, what that means is she makes $12 per hour. So for every hour she works, it's $12. So how many hours is she going to have to work to get $120? Well, if she makes $12 per hour, 120 divided by 12, it's going to give you 10 hours of work. Right? Because you could have done it where she earns $120 is going to equal 12 times however many hours she has to work. So then you're dividing 12 by 12 and 120 by 12 to get your 12 hours, or your 10 hours. Anna makes $10 per hour. Write and graph a linear function to represent her earnings. Compare your slopes. What does this mean in context of the problem? So if you went up here, if Anna makes $10 per hour, that means for 1 hour she works. So this is Janet's. Anna, for 1 hour she makes $10. 2 hours she makes 20. 3 hours she makes 30. 4 hours she makes 40. 5 hours she makes 50, so on and so forth. So if I was to draw that line right there, that's Anna's. Okay. It says down here, Anna makes $10. Write and graph a linear function. So write it and graph it. We just graphed it, but now we're going to write it. So it's going to be y equals whatever I'm doing to x to get to y, timesing it by 10. So y equals 10x is Anna's. Compare their slopes. Well, Janet's slope is steeper. And what does that mean in context of the problem? So she makes more money. She makes $2 more per hour. All right, so when you're looking at direct variation, it's what am I doing to X to get to Y? Each time I'm only doing one thing to it. Then they vary directly. It also, so all your ordered pairs are going to be proportional to one another, and it has to go through the origin for it to show direct variation.